Hello children, let's understand some important properties of nonmetals. So children, I'm sure you have understood the uses or the importance of nonmetals in daily life. Like nitrogen and oxygen, they are actually required for animals breathe in the oxygen for respiration. Plants also respire and they also need oxygen. They need carbon dioxide for photosynthesis. Nitrogen is required by plants for the because it's the main nutrient to make proteins, right? Nitrogen is there present in proteins, so it is also needed by plants in the form of nitrates and nitrites. Not only that, water contains hydrogen and oxygen. So there are many nonmetals that we use in daily life, and so the question arises that what are the physical properties of nonmetals? How will you say that this is a nonmetal? So children, as you have seen the periodic table, and in the periodic table, there are 118 elements known to us, out of which there are 92 metals. And what are rest? The rest elements are either non-metals or they are metalloids, right? So now, when you look at the right side of the periodic table, I am showing only the right side of the periodic table. So see, these are non-metals: carbon, nitrogen, oxygen, phosphorus, sulfur, selenium, hydrogen, fluorine, chlorine, bromine, iodine. And what are these? This boron, silicon, germanium, arsenic, antimony, tellurium, they are metalloids. The zigzag line belongs to metalloids, and the right side of the metalloids in the periodic table is non-metal. Children, we don't classify them as non-metal now. We call this 18 group as noble gases. These are noble gases. Though we can do classify, that's fine because they belong to the right side of the periodic table. But still, the correct naming of this helium, neon, argon, krypton, xenon, radon, it is noble gases because they have complete octet. Their last shells are completely filled. So we don't classify them as non-metals now. So on proceeding further, let's understand the physical properties of non-metals. So when you do the same activities for the non-metals, suppose you have taken coal or you have taken graphite as carbon, because carbon is actually coal, graphite, diamond, you can take any, and then you can take sulfur and iodine, which are easily available non-metals in your chemistry lab. Then what you have to do in the activity? You have to observe the physical properties of non-metals. How will you do? You have to perform the same activities that we did for metals. What did we do for metals? You have to do the test for conduction of heat, conduction of electricity, then you have to hit their surface with the hammer, you have to cut them by knife, and then you have to beat them and see whether sound is produced or not. So all the properties or the activities that we performed with the metals, you have to perform the same activity with the non-metals. So what are the samples that we are taking? We are taking carbon in the form of, you can take coal or you can also take graphite, and then in the lab you will also get sulfur. So it is very easy and convenient to use sulfur as a sample of non-metal. Then you can take iodine crystals for the same purpose, and then you have to check all the activities, you have to perform the activities on all these three samples. So what will we observe? So when we will observe these activities, we will find out the following observations. Let's write them in the tabular form. So children, first of all, we have elements carbon, sulfur and iodine. What are the symbols? Carbon has symbol C, sulfur has symbol S, and what is the symbol of iodine? Children, the symbol of iodine is I. Now what about the type of surface? So when you will touch the surface of coal, you will find that it has porous structure, right? So though it is a solid only, but it has a porous, coarse structure. Then sulfur is also solid, it's a yellow solid, right? Carbon coal is black in color, sulfur is yellow solid, and it has a powdered appearance, though there is a correct term, amorphous. Then iodine Iodine is also a solid. It's a beautiful violet color crystals, and it is crystalline because I said it is like a crystals. So what you will find for the hardness? So when you will observe coal, is it really hard? No, it is actually brittle, right? So all non-metals actually they are brittle, they are not hard. Similarly, sulfur, it's already a powdered form, so definitely it's a brittle. And iodine crystals, though they are crystals, but still they are not as hard as metals, so they are brittle. So all metals are usually brittle, they are not as hard as metals. So now when we look for the other properties, now think about malleability. Are non-metals malleable? Can they be converted into thin sheets? No, it's not possible. So what is malleability? Converting into thin sheets. Can you convert coal into thin sheet, sulfur into thin sheet, or iodine into thin sheet? Answer is definitely no, it's not at all possible. Ductility. Ductility means converting into thin wires. Can you convert them into thin wire? Have you seen any wire of carbon or sulfur or iodine? No. So they cannot be converted into thin wires. The answer is no, definitely. Conducts electricity. If you are taking carbon as a sample and there is coal, so coal is a bad conductor, but if you take graphite as a sample, it's a good conductor, which is an exception to conduction of electricity, but generally non-metals are poor conductors of electricity. So definitely they do not conduct electricity because here we are taking carbon as coal. So if carbon is coal here, it is definitely a poor conductor, but if you have taken graphite, the answer will be different. Then you have to write yes, graphite is a good conductor, but not all carbon forms are good conductors, mostly are bad conductors. So they all are poor conductors. So no, no and no for carbon, sulfur and iodine. Now what about the last, sonority? When you beat them, they will not produce any sound. So when they will not produce any sound, it means that carbon is non-sonorous, sulfur is non-sonorous, and iodine is also non-sonorous, right? So this property clearly indicates that what are the physical properties of non-metals? Non-metals are non-lustrous, but yes, there is an exception. There are two non-metals which are lustrous, iodine and diamond. They are exceptions, right? They have lustrous appearance, right? Then they all are brittle, they are not hard, but again there is an exception, diamond. Diamond is one of the hardest substance known, but rest of the non-metals are brittle. Also, they are non-malleable, non-ductile, they cannot be converted into thin sheets, thin wires. They are insulators. Again there is an exception. Though they are poor conductors of electricity and heat, but still there is an exception, graphite. It is an allotrope of carbon, it's a form of carbon, but it is a good conductor of electricity and heat. Why it's a good conductor? What does it contain which makes it good conductor? Actually, it contains free electrons. Yes, its structure contains free electrons which actually conduct electricity and make it a good conductor. Now, low melting point, they all have low melting point, they are non-sonorous in nature, and hence we can say that these are the properties of non-metals and the activity clearly proves all these properties. I hope you have understood. Thank you.